Hello students, this is Shachi. Welcome to my channel Crack Chemistry. Today I am going to explain a class 10th topic. The name of the topic is metals and non-metals. From this topic I will discuss exemplar problems. Today's session is part 4th. For previous videos, please check the I button. Students, before starting, I want to remind you to subscribe my channel for getting information about further important uploads, and press the like button if you like this video and share this video with your friends also. So now come with me and let's crack chemistry. So our first question is, although metals form basic oxides, which of the following metals form an amphoteric oxides? So children, one point I would like to share here, that metals form basic oxides. Basic oxides means when metal oxides dissolved in water, they form bases. So if we consider the given options, we can see the first option is sodium. Sodium forms a basic oxide. The basic oxide of sodium is Na2O. So when sodium oxide is dissolved in water, it forms a base which is NaOH. So hence sodium forms a basic oxide. If you look at calcium, calcium also forms a basic oxide. The oxide of calcium is CaO. And when this calcium oxide is dissolved in water, it forms a base which is calcium hydroxide, CaOH taken twice. So option A and B are not the correct options. Now if you look at the option C, which is aluminium. Aluminium reacts with oxygen and form an oxide Al2O3. And children, Al2O3 is an amphoteric oxide. So what are amphoteric oxides? Amphoteric oxides are those oxides which react with both acids as well as bases. So aluminium oxide reacts both with acids and bases. So aluminium forms an amphoteric oxide which is Al2O3. And if you look at the last option, which is copper, copper also forms basic oxide. So our correct option is option C. I hope this question is clear to you. Now look at the next question. Next question is, generally non-metals are not conductors of electricity. Which of the following is a good conductor of electricity? So children, you already know that metals are good conductors of electricity, but generally non-metals are not conductors of electricity. We have an exception here. What is that exception? That exception is graphite. Children, graphite is an allotrope of carbon. The arrangement of graphite is like that. One of the electron in graphite is free. So this free electron is responsible for the conductivity of graphite. If we look at other options, option A is diamond, which is not a good conductor of electricity because it doesn't have any free electron. If we look at the option C, which is sulfur, sulfur being a non-metal, it is also not a conductor of electricity. Similarly, option D is fullerene. It is also not a good conductor of electricity. Fullerene is also an allotrope of carbon. Children, whatever options have been given, option A, B and D all are the allotropes of carbon. So among these allotropes of carbon, the conductor is graphite. The credit goes to its structure. Because of the presence of free electrons, its electrical conductivity increases. Next question. Electrical wires have a coating of an insulating material. The material generally used is. You have been given 4 options. First option is sulfur. So children, first we will see what is the purpose of coating the electrical wires with an insulating materials. So we know that as electrical wires are made up of metals, they are the good conductors. So to prevent a person from the electric shock which comes in contact with the wire, electrical wires are coated with an insulating material. So what should be the characteristic of insulating material? The material which is used for insulating electrical wire must be a non-conductor. So if we look at the given options, first given option is sulfur. So we know that sulfur is a non-metal, it is a non-conductor of electricity, but it cannot be used as a coating material because it's powderous in nature. So because of the powdery form of sulfur, it cannot be coated on the electrical wires. If we look at graphite, graphite is a conductor, so the purpose cannot be solved if we coat the electrical wire with graphite because graphite itself is a conducting material. Option C is PVC. Children, PVC is an insulating material. It's a polymer. Its full form is polyvinyl chloride. So your correct option is PVC. PVC is used as an insulating material for coating electrical wires. And the last option is all can be used. This is also a wrong option. So I hope this question is clear to you. Now look at the next question. Question number 34 is which of the following non-metal is a liquid? Children, among all the non-metals, the only non-metal which is found in liquid state is bromine. So bromine is the only non-metal which exists in liquid state. If we consider other given options, we can see option A is carbon which exists in the solid state. Option C is phosphorus. This also exists in solid state. Option D is sulfur. This also exists in solid state. So most of the non-metals either they exist in the form of solid state or in the form of gaseous state. But the only non-metal which exists in liquid state is bromine. So your correct option is option B, bromine. I hope it is clear to you. Next question. Next question is which of the following can undergo a chemical reaction? So children, if you look carefully at the given options, you can find that you have been given a salt of metal and it is allowed to treat with another metal. So you have been asked whether the reaction will take place or not. For answering this question, you must know the reactivity series. Always remember that if a more reactive metal is added to a salt solution of less reactive metal, the more reactive metal will displace less reactive metal from the salt solution. For solving this question, you must know the reactivity series. So for your convenience, I have written reactivity series here. Reactivity series you can learn by a very simple mnemonic which is PSC, Mezentle, HCHAP. I repeat, PSC, Mezentle. Mezentle means M-A-Z-I-N-T-L, HCHAAP. So P stands for potassium, S stands for sodium, C stands for calcium, M stands for magnesium, A stands for aluminium, Z stands for zinc, I stands for iron, N stands for nickel, T stands for tin, L stands for lead. And surprisingly, you will find that after lead in the reactivity series, a non-metal has been placed, which I have written with the help of a red color ink, which is hydrogen. So what is the purpose? Why hydrogen has been placed in the reactivity series of metals? Children, the answer for this question is that hydrogen can also lose electrons like metals. There are some metals which have such a less reactivity, they donate electrons even at a slower rate than hydrogen. So these metals have been placed below hydrogen in the reactivity series. Anyways, we will go back to our given options. So first given option is magnesium sulfate plus iron. For answering the question whether the reaction can take place or not, you have to find out position of magnesium and iron in the reactivity series. You can see that magnesium is written as M in the reactivity series. So this is magnesium. What about iron? It has been shown with the help of symbol I. So it is clear to you that as iron is less reactive than magnesium. Why it is less reactive than magnesium? Because it is placed after magnesium in the reactivity series. So therefore this reaction cannot take place. Because iron is less reactive than magnesium, so a less reactive metal can never displace a more reactive metal from its salt solution. So reaction A is not possible. Now consider the reaction B. Reaction B is ZnSO4 plus Fe. So children, consider the position of given metals here in the reactivity series. So where is Z? Z I am showing you with the help of a circle, and I, you already know that I represents iron. So as iron is placed after zinc in the reactivity series, this reaction can also not take place. So option B is also the wrong option. Now look at the option C. For explaining option C, I will clear the points which I have written here so that it will become more clear to you. Now consider the option C. In option C, you have been given magnesium sulfate plus lead. So children, again find out the position of magnesium. This is magnesium, and where is lead? Lead has been given by the letter L. So again, as lead is less reactive than magnesium, lead cannot displace magnesium from its salt solution. So reaction C is also not possible. Now look at the last option. In the last option, you have been given copper sulfate plus Fe. Children, find out the position of copper. Copper is placed after hydrogen. In the reactivity series, it has been shown by the letter C, and iron has been represented by the letter I. So you can see that as iron is more reactive than copper, this reaction will take place. So iron can displace copper from copper sulfate solution. And one more interesting point I would like to discuss here, that as iron is more reactive than copper, it will displace copper from copper sulfate solution, and it will form FeSO4 plus Cu. Children, you know that color of FeSO4 is pale green, and you must know the color of copper sulfate. The color of copper sulfate solution is blue. So after this reaction, the color of solution changes from blue to pale green. So our correct option is option D. I hope it is clear to you. Next question. In this question, you have been asked which one of the following figure correctly describes the process of electrolytic refining. What is electrolytic refining, children? Electrolytic refining is used for the purification of metals like gold, silver, etc. So first we will see what is refining. Refining is the process of purification of metal which is obtained after a series of metallurgical operations. Because after a series of metallurgical operations, the metals which we get is still not 100% pure. It has some impurities. For removing these impurities, metals are subjected to the process of refining. Electrolytic refining is one of the methods which is used for refining of metals. Electrolytic refining is used for refining of metals like gold, silver, etc. So what we do in electrolytic refining, I am going to explain you. For example, during the refining of copper, you will take the impure copper in the form of a rod, and that impure rod will be made as anode. It will be made as an anode by connecting this rod to the positive terminal of the battery. So I'm writing here the impure rod will be made as anode. Another point is that a thin strip of pure metal will be taken in the form of cathode. In the form of cathode means it will be connected to negative terminal of the battery. So I am writing here that pure rod will be made as cathode. After selecting anode and cathode, I will discuss the reactions which take place at anode and cathode. Children, at anode, oxidation will take place. Oxidation means loss of electrons. So as we have seen that impure rod was taken as anode. So at anode what will happen? The metal will lose electron and it will pass into the solution, and electrons will be left behind at anode only. So suppose I am discussing copper as an example. So at anode, copper will lose 2 electrons and will convert into copper ion. So this is the reaction which takes place at anode. So what will happen? We have taken impure rod of copper as anode. So at this anode, the copper atom will undergo continuous oxidation. By the process of oxidation, they will convert into copper ion, and which will pass into the solution in the dissolved form. And what about electrons? Electrons will be left behind at the anode only. So this was the reaction which took place at anode. Now we will consider the reaction which takes place at cathode. At cathode, equivalent amount of copper ion will be deposited by the process of reduction. Equivalent amount of copper ion means, just now we have discussed that during oxidation, copper will be oxidized into copper ion and will go into the solution. At the same time, same amount of copper ion will be deposited at cathode by the process of reduction. Reduction means gain of electrons. So I'll show you by the means of chemical reaction. So you can see here at cathode, Cu2+ will take 2 electrons from the cathode and will convert into copper. So now you must be understanding that during the process of oxidation which is taking place at anode, a continuous loss of copper atom is taking place. Copper atom from the impure copper rod will continuously pass into the solution, and at the same time equivalent amount of copper will be deposited at cathode. So it's quite clear, you must be understanding that during this process the anode will become thinner and thinner and cathode will become thicker and thicker. So this is the principle of electrorefining. At the end of the electrorefining, only impurities will be left behind at anode. And one more interesting point I would like to share here, sometimes some precious metals like gold, silver, etc. are found to be associated with the metal. So during this process, they get deposited below anode in the form of anode mud. So these impurities can also be used to separate these precious metals from the anode mud. I hope it is clear to you. So now we will see what is the correct option. One by one we will consider all options. So option A, you can see that anode has been connected to negative terminal of the battery. So this is a wrong statement because anode is always the positive electrode. It is connected to positive terminal of the battery. Now look at the option B. Option B shows that cathode is negative here. So this point is correct. Anode is positive. This point is also correct. Now look at the reactions which are taking place at anode and cathode. As we have seen that at anode oxidation takes place. Oxidation means loss of electron. So you can see here in option B, from anode the metal atom is continuously converting into Cu2+ ion, means oxidation is taking place, and at cathode what is happening? The copper ion is getting deposited at cathode. This point is also correct here. But if you look at impurities are present here below cathode. This is not a correct statement because during the process of electrolytic refining, impurities get collected below anode. That's why they are called as anode mud. So anode mud means impurities which may contain some precious metals like gold and silver are collected below anode. So I am writing here anode mud. So in the diagram B, all the options are correct, but only anode mud has not been shown at the correct place. Now look at the option C. In option C, anode is connected to positive terminal of the battery. This is the correct statement. And cathode is connected to negative terminal of battery. That is also a correct statement. Now, what is happening at cathode? You can see that at cathode reduction is taking place because Cu2+ is getting deposited at cathode. This is also a correct statement. And at anode, oxidation is taking place. Copper atom from impure copper rod is continuously passing into the solution by the loss of electrons. This is also a correct statement. And now the last point we will see, the impurities. Impurities means anode, mud, has been shown below anode. So this is also the correct statement. Option C is the correct option. So children, I hope it is clear to you. Your correct option is option C. So option C is the correct option. I hope each and every point is clear to you. Children, thank you so much for watching this video. I hope each and every point is clear to you. Please subscribe my channel and share this video with your friends also, so that I can make many more important videos for you. Thank you so much. Have a nice day.